It used to be in geometry, it's not anymore. A locus is just a set of points. Now, if I asked you guys to define a parabola, look at me. Most of you would probably say, oh, it's one of those shapes that just goes like this, right? You do it with a visual, okay? Obviously, we can't define things like that in math. What a parabola really is that you guys have never been told is it's all of the points that are equidistant, all the points equidistant from a fixed point and a fixed line. Okay? The fixed point is called the focus. The fixed line is called a directrix. So you're going to be given a lot of times a focus and a directrix, a fixed point and a fixed line. So in exercise 1, our fixed point is at 3, 2. Plot that. And a fixed line, y equals 6. 1, 2, 3, 4, 5, 6. That's a horizontal line. So I'm going to label this F and 3, 2. And I'm going to label this directrix, y equals 6. So any point on the graph, and there are an infinite number of these points, that are equidistant, meaning the same distance away from the line as they are from the focus, are going to create a parabola. So where is the most obvious point that's an even distance away from both of these, from the focus and from the directrix? What would the coordinates be, Andrew? 3, 4. So he's pointing right here. He's saying this point is an equal distance away from the directrix as it is from the focus. Do we all agree? That is 100% the most obvious one. It's 2 away from the line and 2 away from the point. Okay? That's your vertex. The most obvious version of this is your vertex. So your vertex is at 3, 4. It's perfectly halfway in between those. It gets a little bit trickier. So that's 2 and 2. If you get something that's 3 units away from both, it's a little bit trickier, and I'm going to pretend it's like this. I don't know, somewhere over here, we'll say. Okay? That's 3 units away from the line. It's harder to realize that that's also 3 units away from the point because you can't count diagonally, right? So the other points aren't as obvious, but ideally what's happening, I'm just doing this lightly, is that that's 3 units and that's 3 units. When you get a little further away to 4 units away and 4 units away, that's 4 units away and that's 4 units away, approximately, right? And so what's going to happen is all of these points make the parabolic shape, and the same thing's going to happen on this side. So your parabola is made up of the set of all points, which there's an infinite number of points that are an equal distance away from the directrix. Let's say this is 9 units away. Then that's 9 units away from the focus. Does this make sense? Okay? So a couple things. Your vertex is always perfectly halfway in between. The other thing is that your parabola always kind of encloses the focus. If you think of your parabola like a bowl, the focus is inside the bowl, right? And it always bends away from the directrix. Is this clear? Okay, because what we're going to be doing here shortly is writing the equation of a parabola based on the focus and the directrix, based on that fixed point, based on that fixed line. And you've really, up until this point, only written equations of lines, right? You've never been asked to write equations of parabola from my knowledge. So we're going to have to do that given the focus, given the directrix. So we've plotted the point and the directrix, the focus and the directrix. We've sketched appropriately the parabola. Now we are going to write the equation of the parabola using the distance formula concept. And you know what? I might skip that and only come back to it if I have time, because there is a more efficient way of doing it that we're going to discuss, okay? The distance formula concept, without going through the entire thing, says that any point, so if I call any point on the parabola point P, any point P, its distance away from the directrix, so the point to directrix distance, I'll do distance point to directrix, has to equal the distance from the point to the focus, point to focus. Okay, distance point to directrix equals the distance point to focus. And I'm not going to review the distance formula right now unless we have time. I will come back to that to show it to you, but there's a much easier way. Okay? So the first thing I want practice on. Anytime you're given 2 out of the 3 of these, anytime you're given out of the directrix, the vertex, and the focus, if you're given 2 of them, you should be able to find the third. Just based on the fact that the vertex is always halfway between the focus and directrix. Maybe we ought to write that down here. Vertex is always halfway between, and you'll usually just count it out, the focus and directrix. And you can't count it out without a picture. So I'm always going to encourage you to sketch a picture first and foremost. So for part A, sketch a quick graph. We have a focus at 6,2. And a directrix at y equals -4. So take a minute and tell me where you think the coordinates of the vertex are. On your own, take a minute to try to come up with the coordinates of your vertex, and then we'll see how we do with that. McKenna, what do you think? Where's the point that's halfway between the focus and the directrix? So 1, 2, 3, 2, right here? Okay, so could you go up and point to the point that's halfway between, approximately? Go up there and put your finger at a point that's halfway between those two. I'm going to label this F for focus. Where's approximately the halfway point? Okay, I can't see because you're in my way, so turn. Let me see. Point to where you... So this right here, is that fair? You think that's equally as far away from this as it is from this down here? No, that's much closer to the focus, so try again. Yes, something in here. So let me ask you this, McKenna. How far away are these two? This one's at +2, this one's at -4. So how far away are those? How many units? 6. So it's half of 6. 3. So we want to go 3 below this one, which should also be 3 above this one, right? So what are the coordinates of that going to be? If we go 3 points below this, 1, 2, 3, where are we? The point 3, 4 is way the heck up here. So what's the x coordinate of this point? It's 6. It's perfectly underneath the focus, so it's also 6. And what's the y coordinate? 6 4s up here. What's 3 units below 2? -1. So this is the point, 6, -1. Do you follow that? Any questions on that? Good, you can sit down. Thank you for participating. Good job. Okay, so it's not an easy concept. Some people are going to grasp it easier than others, obviously, as everything. But you have to kind of count it out. And I think one key point of all of what I just went through with McKenna is how far away are the focus and the directrix. And once you realize they're 6 units away, you just have to go kind of 3 and 3, 3 below, 3 above, and come up with that point. So that is the vertex here is 6, -1. Now, does this parabola open up or open down if it has to contain the focus? If it's a bowl that contains the focus, will it open up or open down? Kaylee Smith. Up. It's got to contain the focus, and it's always got to bend away from the directrix. So a brief, quick sketch of this parabola would look something like that. So what does that tell us then about the A value if we were about to write this equation, Cameron? If this opens up, what do you know about the A value? It's positive. We'll get there. Okay? Any questions so far? Okay, let's move to B, where we're given the focus and the vertex, asked for the directrix. So quick sketch again. Plot your focus at -3, 2. And that's our focus. Our vertex is at -3, 3. So it's just 1 unit above. So take a minute and think about where would our directrix then have to be if the vertex always has to be halfway between the two of them. Where would our fixed line be so that the vertex is halfway between the focus and the line? Evan. Y equals 4. Does anybody think something else? Raise your hand if you agree. Maggie, did you think it's something else? What did you think? If I put it at y equals 1, now the focus is halfway between the other two. I want the vertex to be halfway in between. So if the focus is 1 unit below, then the directrix has to be 1 unit above. So Evan is correct. The directrix is at y equals 4. And which way should this parabola sketch open? Up or down? Isaiah. Very good. Bends away from the directrix. So that will have an A value that's a negative number. How are we doing? Good? Okay. And then for C, given the directrix and the vertex, this one's a little bit crazier, so I'm going to talk you through this because what do you notice about the directrix? X equals 5 is what kind of line? Vertical. So now we've got a directrix that's vertical. That's okay. And our vertex is -2, -1, 2, 3, 4, 5. That vertex has to be halfway between the directrix and the focus. Raise your hand if you think you can tell me what the focus is already. Cameron? The focus is going to be a point, not a line. Aiden? Very good. Now, this is trickier, but look up here. The vertex to the directrix right now is 7 units, right? From +5 to -2, that's 7 units away. So since the vertex has to be halfway in between, we need to go 7 units back this way. Do you follow? Focus. And 7 units further to the left than -2 is -9. And the y-coordinate is going to be the same as it already was because we're still 5 units below. -9, -5. Really nice job, Aiden. So now, your vertex, now this isn't about opening up or opening down. Is it going to open left or is it going to open right? Left, because it needs to contain the focus. Does that make sense? Any questions on that? So as far as an A value for this, it's opening towards the negative numbers, right? Like towards the negative x values, just like this is opening towards the negative y value. So this was a negative A. This is also going to be a negative A because it's opening towards the negative x values. All right. So do we follow the concept of the vertex having to be halfway in between? Okay. Now, writing. Okay. Here's the format that we've worked with and we worked with yesterday. Okay. This is for our typical parabolas y equals. So these are the ones that open up and down. Okay? Once you know the vertex, h and k, just plug them in. The a value comes from this. Kind of box these in so they don't look like all the same thing. The a value comes from, and the plus or minus you have to decide on your own based on your sketch. Is it opening up or opening down? The plus or minus you have to figure out and think through. But the a value comes from 1 over twice the distance between the focus and the directrix. Okay? We'll come back and we'll interpret that phrase in a minute when we do exercise 2. Sketch it. Always sketch. We're going to try to write the equation of a parabola with a certain focus and a certain directrix. So sketch it. The focus is at 0, 2. And the directrix is just the x-axis. So we sort of already have that right here. So the first thing you have to do is come up with the vertex on your own. Where is the vertex? Kaylee M. Is that vertex up here, 0, 4, is that halfway between the focus and the directrix? No, what is halfway between the focus and the directrix? 0, 1. Your vertex is 0, 1. Get that down. Second question for your sketch. Is my parabola going to open up or down then, John? Up, because it has to contain the focus. So we know our a value is positive, right? Okay, so I'm going to write down the format that we have to always plug into. And I'm going to start plugging things in. Our a value is positive. Now, we're going to go back to what we said a was above, and you have to memorize this. We already know it's positive because it opens up. It's always 1 over double the distance between the focus and directrix. How many units away is this focus from this directrix? 2? Do we follow that? Connor, you with me? That's 0, 2. 1 unit, 2 units away. Focus to directrix is 2 units away. So double that distance is going to give me a 4, 1 over 4 eventually. What's my h? Micah? What's my h and what's my k? Someone help him out. HK is the vertex coordinates. This is h, this is k. So h is 0, so x minus 0 squared plus 1. And then this we will just reduce. It's 1/4. X minus 0 you don't really need, so just x squared plus the 1. Any questions? Okay? Next one. Sketch it. There's my focus. -2, -4. Directrix is vertical again. So big question. Where's my vertex? Oh, this is an ugly one, huh? Why is it ugly? Nate? Right, so halfway, so these are 3 units away, so halfway between, and that's okay, is 1.5 units away, so it's going to be -0.5, -4. It's going to be down here. -0.5, -4. I do not think that's going to happen very often, but it is what it is, okay? And which way does our parabola open, to the left or to the right? Left. It's got to contain the focus, so there's your sketch. Now, the sideways parabola goes with a different equation. So up top, rather than y equals, it's x equals. Rather than hk, it's kh. Do you see the difference there? It's very similar, but it's got the hk flipped and the x and the y flipped. So I'm going to write that down below. X equals a, y minus k squared plus h. And I'm going to plug in x equals my a value. Again, look up here. It's opening towards the negatives, so it's a negative a value. It's 1 over twice the distance between the focus and the directrix. Nate told us already they were 3 units apart. Focus to directrix, 3 units. So double that is 6. Micah, what's my k value? -4. Y minus -4. You'll see why that turns into plus, right? Plus my h value is -1/2. Now we just simplify. X equals -1/6, parentheses y plus 4 squared minus 1/2. Andrew. It's just the format rule. If it's an up and down parabola, it's HK. If it's left and right, it's KH, because the X and the Y switched. Now, here's the thing I will tell you. I really don't think they're going to give us a sideways parabola on the Regents ever. They say it's in our curriculum, but like Mr. and Mrs. Hill aren't even teaching this. They're not teaching the left, they're just gambling that it's not going to be on there. It's not too different, so I'm showing it to you, and I want you to practice it, but I really don't think it's going to be on there, because this whole course is called the story of functions. That's not a function, right? It fails the vertical line test. So I don't think it's going to be on there. So when I have you memorize the parabola vertex format, it's always going to be the y equals one, the HK one. But I just figure show it to you because it does have it in some of the state stuff for you. Now, on your homework, all these 3 examples on the back were giving you focus directrix, focus directrix, focus directrix. On your homework, it's going to give you, some of them are going So it's just the front side, your answers are on the back. The first 6 are like the activity that we did on the back here, or on the front rather, where we just kind of drew out and found the missing one. 7 is a tricky one, so we'll probably definitely go over that tomorrow. And then on 8, it's just a multiple choice question, okay? And then 1 through 6, once you find the missing part, it says to find the missing part, and then you have to write the equation. So I'm making you find the 3rd missing piece first, so do a sketch on your separate sheet of paper, find the missing piece, then write the equation like we did.